Well, we have created our curve. We no longer need the reference image, so we can hide it by clicking on the eye icon inside the outliner. Then we can go and perform a circular extrusion of our template to go and create our vase. Before we do this, we will need to convert it to a mesh. The convenience of having a curve is also that we can decide how dense to make this mesh. We can, for example, set a high resolution value, say 20, and then eventually go in and delete too many vertices. The important thing is that these are properly distributed along the curve we have defined. Before performing this conversion, let's create a backup copy. That way, if we realize that we didn't like the conversion to mesh, or we need to go in and edit later, we will have the ability to do it very easily. So let's duplicate it with Shift+D, and within the outliner, let's go and rename it with, instead of 1, I, for example, use the abbreviation BK, which stands for backup, and like all backup objects, I'm going to move them to a collection specifically for that. I press the M key to call up new collection. I call this collection just BK, which stands for backup. Of course, you guys can use whatever name you like. Since this is a collection that is not to be rendered or reused, except in extreme cases, I am going to disable all icons. So everything within the collection BK will be neither selectable, nor visible, nor renderable. Well, let's go back to our curve that defines the outline of the vase and right-click to invoke the Convert to Mesh command. We see that the icon has changed. It is no longer a curve, but it is indeed a mesh, and if we go into edit mode, we see that all the vertices are there. These vertices are more or less dense depending on the distribution of control points, so there will be points where we will have an overabundance of vertices, and points where there will be fewer of these vertices. So if, for example, we are unhappy with this point because maybe we wanted to have more vertices in this portion, we can go back, increase the resolution of the curve, and then go back to reconvert it to mesh. Conversely, there are points where it is not absolutely necessary to have all these vertices. For example, from here to here, we don't need to have them. We can delete them, though, while keeping the connection between the remaining vertices with the dissolve command. This command we can easily invoke with the abbreviation Ctrl+X, and we see that all these vertices are gone, so the edge has become perfectly straight. Same thing we can do for the base vertices. From here to here, we can select all of them. I remind you that to select the whole sequence of edges or vertices between one vertex and another, we can do it by holding down the Ctrl key. Then with Ctrl+X, we go to dissolve these vertices. Let's go and see where we can maybe remove some of the vertices. For example, I judge that they are quite well-distributed vertices of this portion, so these become a little bit dense. We can dissolve one yes and one no. We can select them with the Shift key. Of course, feel free to decide how dense to leave these vertices. Here I would even remove 2 yes and 1 no, because here the curve is quite wide, and so with Ctrl+X we are going to fade them. Again, it doesn't make sense to keep so many vertices, so I will delete at least 2 at a time. Here, even 3 or 4 in a row. Do this, of course, according to what you think is appropriate. With Ctrl+X, we go to dissolve them, so we can dissolve a lot more of them, also because the inside of the jar is less visible, so we can make the mesh much less dense. Eventually, no one forbids us to go and make manual shifts. And there we have finished performing the cleaning. As you can see, there are more vertices on the outside, and there are also more vertices where we have tighter curves, for example, on the rim of the jar. To now make the bottom of the jar perfectly flat, we should go and align these vertices with each other. We can do this by using Snap, very simply, but we can also do it by using another very interesting system, which is to scale the two objects along the z-axis by setting the scale factor as 0. Let's do it. We select them both, press the S key to scale, Z to constrain along the z-axis, and then 0 as a parameter. By doing this, we have made the two vertices perfectly horizontal. Same thing we can do for these other two vertices. We need to make them perfectly vertically aligned. We will then scale them along the x-axis. so say cox to constrain us along the axis, and 0 to scale it. How do we make them match exactly with the 3D cursor instead? We can always use the snap, of course, but we can also use a very convenient function of Blender, which is to go and indicate what the pivot point of an operation is. The pivot point is that reference point that is taken into account when we go to perform operations. Let me give you an example. We want to make sure that we scale to 0 along the x-axis, then vertically align these two vertices, but we want to make sure that they are perfectly scaled at the 3D cursor. We will use the 3D cursor itself as the pivot point. Let's go to the Transform Pivot Point menu and select, instead of median point, that is the 3D cursor. Then we press S to scale, X to constrain along the axis, and set the value to 0. There, the vertices have been moved along the x-axis, but since the pivot point is the 3D cursor, here they have been aligned to the latter. Let's go to see one more example of how the pivot point works. We said that right now it is the 3D cursor. So if I, for example, now press the R key, you see that the rotation occurs precisely with a center that corresponds exactly to the 3D cursor. You see that the hatch connecting the mouse cursor to the center of rotation goes precisely to the 3D cursor. Let's press ESC to cancel the rotation and give it a try. Let's move the 3D cursor to this point. You see that the center of rotation has changed because we moved 3D cursor. With Shift plus S, we are going to move 3D cursor back to the center of the origin, so cursor to world origin. So let's go and reposition the pivot point to the median point. We will still come back later to talk about the pivot point, but I still encourage you to experiment in both edit mode and object mode. What we are going to do now instead is extrusion. We're going to create this vase of ours. To tell Blender that we want to rotate this silhouette that we created with the curves, we're going to go and use a modifier. Modifiers are actual algorithms that go to apply changes to our objects. Hence precisely the name modifier. We find them inside the Properties editor in the Modifiers section, that is, the ones indicated by the wrench icon. Let's click. We see that nothing appears because there is no modifier. There is an Add Modifier button though. We click it. Blender shows us a menu that shows us a whole series of available modifiers. The one that we're going to use for this case is from the Generate group, which go to generate some geometry. And if you also look at the icon, we see that there's one just right for us. You see this sort of spiral, the screw modifier. We click on it and we see that we get some kind of a circumference. What we have to go and vary from this modifier is the application of the axis of rotation, since when we inserted the curve we had told Blender to rotate it to see it parallel to our reference image. We will find in our item information a rotation on the x-axis of 90 degrees. So, since this rotation usually occurs on the z-axis, Blender does not know that our z-axis is rotated 90 degrees. So we have to tell Blender that 90-degree rotation we made at the beginning, we want to eliminate it. That is, we want our curve to be natively rotated the way we distributed it. In short, in a nutshell, we want our pot outline to be vertical without this 90-degree rotation being applied. To do this, we apply the rotation with Ctrl plus A. We go to the Apply command and select rotation. What happened? Actually, our template stayed exactly where it was, not that it rotated, but the rotation factor on the x-axis disappeared. This rotation we had done right at the beginning when we inserted the Bezier curve. So here it is that the evolution along the z-axis that is set in the modifier comes back perfectly. Let's try looking at our vase. You see, with a few simple steps, we have created a shape that is anything but trivial. When we see it like this, it looks perfect. When we see it from above, we see that actually this vase is a bit angular because indeed the number of steps, repetitions, is 16. What we can do is to increase this number, bring it to 32, for example. We see that we have a much more blunt jar. However, by doing this, we increase the geometry by a lot. Note that we can also change this parameter later precisely because we are talking about a modifier. Modifiers, you should know, are algorithms precisely that modify our mesh, and they do it in a non-destructive way. So the screw modifier, we can go and tweak it at any time. I now, for example, can change it back to 16. I see it edgy. Yes, However, I end up with a much leaner scene taking up less memory, and I can maybe tell Blender to set to 32, or even more, the number of passes when it's going to render, because maybe it doesn't make sense now to be in the 3D viewport to have in the 3D viewport a vase that's just perfect, when maybe it's going to slow me down all the rest of the modeling. Now obviously a simple vase is not going to slow down our computer, but let's say instead that we are doing a scene where the vases are 10, 100, 100, 0. We could also make a sea of pots, and obviously when we have 100 zero pieces divided into 16 parts, it's different than having 100 zero pieces divided into 32 parts. So we try to economize when we can, and a good idea might be precisely that of Blender, to keep the number of steps within the viewport low and maybe much higher in rendering. We naturally find this concept in other areas as well when we work in Blender. Let's explore this screw modifier for a moment. We see that the angle is 360 degrees. So we can imagine that if instead of 360 we set 180, then we will only get half a jar. But in this case we don't care, so we put 360, and one thing that can make a difference is the merge option. It allows us to go and merge the first and last vertices of this circular extrusion. That is, if we now wanted to permanently apply this modifier, we would get a perfectly closed mesh, because the first vertex and the last vertex of the rotation is merged into a single element. If we now enter edit mode, we see only our vertices, but not a whole mesh. We can try to view the object in wireframe mode. We can do that up here, and we see instead in this case all the faces that make up our object, but what we can actually go in and edit are just the vertices that make up our outline. Now let's go back to solid view. How do we do instead to have an actual mesh that can be modified as we see fit? Here we can do that by going to permanently apply our modifier. If we click, in this little icon with the down arrow appears a menu in which we find the apply command. Apply will permanently apply this modifier. Before we do this, however, let's use the same principle as before. Let's create a backup copy of our jar. Let's say we regret permanently applying the modifier. Let's keep a backup copy of it. Then we duplicate it with Shift+D, press ESC to leave it where it is, and rename it with, say, the name Vase BK, and move it to Collection BK. We press M, BK. We also rename it with the name Vase, then go to finally apply the modifier. We click in this menu, or we can use the abbreviation, +A, to invoke the apply command. Apparently the only thing that happened was that the modifier disappeared. However, if we go into edit mode now, we all see our vertices, all our faces. We can go and modify them. Now actually our jar is angular because we had used only 16 steps, and we cannot go back because we have already applied the modifier. However, for this exercise it will be more than fine. I'll take this opportunity before we conclude to go over with you these 4 visualization options within the 3D viewport. We have seen that with the first one we can view the object in wire mode, i.e. wireframe. Yeah, this is a way that we have to be able to see through our object. It is also a system that allows us to visualize very complex scenes much faster when there are millions of polygons. Then we have the solid mode, which is the default mode that we already know. We have the material preview, which is a preview of the material that will be applied to our vasi. Finally, we have the rendered view, which is an actual real-time rendering within our 3D viewport. In this case, we see the black vase. We only see the orange outline because, having erased every light source within the scene, Blender does not know how to light our vase. We will talk about lighting and materials later. So for this lesson and the next few, we will focus mainly on the first 2 visualization modes. One last thing I want to point out instead is this icon that is put before these 4. This icon is used to make our object transparent, kind of like we're viewing it with X-rays. We are in solid mode. If we click on this icon, which we can also call up with Alt+Z, we see that our vase becomes transparent, so we can see through. When we switch to wireframe view, this button is activated by default, but no one forbids us to disable it. On a practical level, this button does not have an exclusively visual function, but also practical. For example, if we go into edit mode, deselect everything with Alt+A and click to apply a selection rectangle, we see that we have selected all those vertices that were included in the selection rectangle. We deselect everything with Alt plus A, then we go to deselect the X-ray view. Let's go again and make the selection. And we see that if we now instead rotate the view, the vertices that were behind at the time we made the selection were not selected. So be very careful, because there is a big difference between having or not have this icon turned on. So with Alt plus Z, we can turn transparency on or off, and at the same time we can turn on and off the selection of objects that are behind. Well, we'll stop here for this lesson. Of course, I invite you to experiment. Create your own vase. Maybe take some pictures of the vases you have at home and try making different shapes. As always, I thank you for following along, and we will see you again soon.